The first integrated circuits were invented in 1958. Since then, they have evolved dramatically from being simple, semiconductor devices that fit in your pocket to now being some of the most complex structures ever created by man. We've gone from vacuum tubes to transistors to integrated circuits, and now we are looking at artificial intelligence with neural networks that can mimic the human brain. This is the history of the integrated circuit, how it was invented, and why it changed our world forever. In this video, we're going to go through 5 main categories: discrete, SSI, MSI, LSI, and VLSI, as each of these represent different eras in the evolution of electronics. So let's dive right into it. We all know what a computer is today, but back in the mid-20th century, computers were still very much in their infancy. They were incredibly large and occupied entire rooms full of equipment. The reason for this was because computers were built using something called vacuum tubes. These tubes were used for switching and amplification and were commonly made of glass or ceramic with a base, an anode, a cathode, and a heater. By applying a voltage to the anode and cathode, a beam of electrons would be created, which could then be manipulated by a grid to perform calculations. This process required high voltages and lots of power, which contributed to the massive size of early computers. Additionally, these vacuum tubes had a limited lifespan and were prone to failure, which also made them undesirable for use in electronic devices. The invention of the transistor in 1947 marked a turning point in the history of electronics. Transistors provided a smaller, more efficient and reliable alternative to vacuum tubes, paving the way for the development of portable electronic devices such as radios and calculators. A transistor is a small semiconductor device used for amplifying or switching electronic signals. It is composed of 3 layers of semiconductor material, typically doped silicon, and has 3 terminals: the base, collector, and emitter. Transistors can be used as amplifiers, which means they can increase the strength of an input signal, or as switchers, which means they can turn an output signal on or off. The advantage of using transistors over vacuum tubes is that they are much smaller, consume less power, and are more reliable. This allowed for the development of smaller, more portable, and less power-hungry electronic devices. As the popularity of transistors grew, engineers realized that they could combine multiple transistors onto a single piece of semiconductor material, resulting in the invention of the first integrated circuit. While there are several contenders for the title of first integrated circuit, one of the most notable examples is the invention by Jack Kilby of Texas Instruments in 1958. Kilby's integrated circuit consisted of a single germanium wafer with multiple transistors, resistors, and a capacitor, all fabricated directly onto it. This innovation significantly reduced the size and complexity of electronic devices, marking a major milestone in the history of electronics. While the first integrated circuits were bulky and unreliable, they paved the way for future innovations. In 1961, Robert Neusser Fairchild Semiconductor and Wolfgangus von Zeuben of Sylvania independently developed planar integrated circuits, which were much smaller and more reliable than previous designs. These advancements led to the development of new and innovative electronic devices, such as the Apollo Guidance Computer, which was used in the Apollo space program. The Apollo Guidance Computer AGN, also known as the AGC, was a critical component of NASA's Apollo space program. Developed by MIT's Instrumentation Laboratory, it was responsible for guiding the spacecraft from launch to lunar landing. The AGC was a highly advanced computer for its time, featuring a clock speed of 2.04 MHz and 36 kilobytes of read-only memory. Its compact design and reliability were essential for the success of the Apollo missions. TTL stands for transistor, transistor logic, and refers to a type of digital logic circuit that uses transistors as its basic switching element. TTL circuits are known for their high speed and accuracy, making them ideal for use in computing applications where fast and precise operation is required. Introduced in the late 1960s by Texas Instruments, TTL quickly became popular among hobbyists and electronics enthusiasts. Due to its low cost and ease of use, TTL circuits are designed to operate with a single 5-volt supply, which makes them more energy efficient than previous logic families. Each gate within a TTL IC can handle up to 10 milliamps of current, allowing for easy interfacing with other TTL devices. The most common types of TTL gates are the AND gate, OR gate, NOR gate, XOR gate, and the D flip-flop. AND gate performs a logical and operation on 2 inputs, returning A1 only if both inputs are 1. OR gate performs a logical OR operation, returning a 1 if either input is 1. NOT gate inverts its input, returning a 1 if the input is 0 and 0 if the input is 1. XOR gate returns a 1 if exactly one of its inputs is 1, and a D flip-flop is a type of memory cell that stores a 1 if its D input is 1 when the clock signal is triggered. Together, these gates can be combined to create more complex functions, allowing for the construction of entire digital systems on a single chip. MSI, or medium-scale integration, is a term used to describe the level of integration in electronic circuits that was achieved in the 1970s. During this period, chips contained between 100 and 1,000 components, such as transistors and diodes, fabricated on a single piece of semiconductor material. This level of integration allowed for the creation of more complex and powerful electronic devices, such as the first microprocessors. One of the key advantages of MSI technology was the increased level of functionality that could be achieved on a single chip. For example, during the 1970s, MSI chips were used to create calculators, digital watches, and other consumer electronics that were not possible to create with discrete components. Another advantage of MSI technology was the reduced size and weight of electronic devices. By integrating multiple components onto a single chip, it was possible to create devices that were smaller and lighter than before. This was particularly important for military and aerospace applications, where size and weight were critical factors. Despite the advantages of MSI technology, it also had some limitations. As the number of components on a single chip increased, the complexity of the design and manufacturing process also increased. Additionally, the performance and reliability of MSI chips were not as good as what was possible with newer technologies. However, MSI played an important role in the evolution of integrated circuits and paved the way for the development of larger-scale integrated circuits. LSI, or large-scale integration, is a term used to describe the level of integration in electronic circuits that was achieved in the 1980s. During this time, chips contained between 1,000 and 1 million components, such as transistors and diodes. LSI technology enabled the development of more complex and powerful electronic devices such as personal computers, video games, and mobile phones. Personal computers, or PCs, are a prime example of the impact that LSI technology had on the electronics industry. The first IBM PC introduced in 1981 contained an Intel 8086 microprocessor, which was an LSI chip with 29,000 transistors. This allowed for the mass adoption of personal computers and eventually the Internet and World Wide Web. Mobile phones are another example of devices that benefited from LSI technology. The first commercially available mobile phone, the Dynatac 8000X, introduced in 1983, contained an LSI chip that allowed for wireless communication between phones and cellular towers. VLS Very large-scale integration is a term used to describe the level of integration in electronic circuits that was achieved in the 1990s and beyond. During this time, chips contained between 1 million and 1 billion components, such as transistors and diodes. VLSI technology enabled the development of even more complex and powerful electronic devices such as smartphones, digital cameras, and network routers. Smartphones are a prime example of the impact that VLSI technology has had on modern electronics. The iPhone, introduced in 2007, contains millions of transistors on a single chip, allowing for powerful processing, high-resolution displays, and advanced wireless communication. Digital cameras are another example of devices that have benefited from VLSI technology. The ability to pack millions of tiny sensors and processing units onto a single chip has led to the development of high-quality, low-cost digital cameras for consumers and professionals alike. Network routers are yet another example of devices that have benefited from VLSI technology. The ability to process vast amounts of data quickly and efficiently has led to the development of high-performance, low-latency network routers that are essential for today's internet infrastructure. So that pretty much wraps it up for the history of the integrated circuit. These inventions have truly changed the world around us. What do you think? Leave a comment down below, like and subscribe if you enjoyed the content, and see you in the next one.